Hello from the lab. In the next video series, we will distill palinka. We will go through a complete distillation process, step by step, with each machine of our in-house product line. All three machines have the same water-jacketed double-walled kettle, with a gross capacity of 100 liters. The machines are available with different heating options, such as gas, electric, or wood. To ensure a proper copper surface, our column still models have a catalysator and copper rings. Here, from the test room, we will show you distillation technology videos, but a separate technical description of the machines will be available as well. And we will also share details about the design and manufacturing technology. In the distillation technology videos, our machines are fully equipped. For more information, please visit our website. The next distillation will be done by our Trias machine. This will be a column still rectification. If we want to do column still distillation on this universal machine, then the direction of the steam will be as follows. It is released in the kettle, and then it goes through the cupola. We have to ensure that through this pipe the steam can reach the bottom of the rectifying column. We can achieve this by opening this tap. The steam will pass through the column, thus performing a column still rectification. It exits through the deflegmator into the line arm, and passing through the line arm, it goes into the end cooler. In the end cooler, it condenses, cools down, drains, and the distillate will flow out through the distilling parrot. Our Trias and Tulip models are also optimized for gin production, so we have installed 3 gin baskets in this aroma tower. A unique feature of our Trias model is that it also has an aroma basket in the upper part of the kettle. Aroma baskets can also be used when making fruit brandies, and are must-have components during vapor-infused gin distillation. During the on-site installation of the machine, it is necessary to connect the water supply cables, which are marked here with blue, while the heated wastewater leaves through the red pipes. It is important that these pipes have a heat resistance of 80 to 100 degrees. The water-cooled deflegmator, the so-called Pistorius cooler, or Pistorius plate, located on the cupola, is connected to the wastewater drain with a quick connector, so the entire cupola can be removed at any times. The overflow part of the water-cooled deflegmator is connected to the drain pipe. If we want to drain it, we can do it with this tap. We must install the breather in the machine. The tap was opened through the distilling parrot, and we prepared for collecting the heads. Before using the machine, fill the deflegmator and the end cooler with water. The rotameter controlling the end cooler is located on the right side. The second rotameter shows the amount of water entering the Pistorius plate in liters per hour. The third rotameter controls the amount of cooling water entering the deflegmator located at the top of the column. You can read the value of the rotameter at the top point of the float. The electric switch box is packed separately from the machine. Connecting it to the machine and placing it around the machine must be carried out at the installation site. The electric switch box is usually mounted on the wall near the machine and must be connected to the heating elements according to the wiring instructions. The filling capacity of the kettle is 80-85 liters. The filling level of Trias, like with other kettles, is the connection point of the mixing end. The water seal of the rectifying column must be facing upwards during distillation. Before starting the distillation, add the silicone water-based anti-foaming agent, which helps prevent the mash from running up, from foaming at the start of the distillation, and from sticking to the side of the kettle. You need approximately a tablespoon of it, 5-10 milliliters. You can put back the glass door and the distillation can begin. We set the sound signal of the mash temperature to 90 degrees Celsius. We set the deflegmator thermometer to 82 degrees Celsius in case of column still distillation. This ensures that if we leave the 79 to 81 degrees Celsius interval, we will be alarmed. If we want to perform column still distillation with Trias, it is unnecessary to use the deflegmator located on the cupola, since the deflegmator of the rectifying column will be operating during the process. On Trias machine, the sensor of the cupola thermometer is located on the exiting pipes, and in case of column still distillation, we suggest setting it to 80-85 degrees Celsius. It will alarm us before the steam reaches the bottom of the column. During the heating phase, if the pressure of the jacket has increased, we can vent a little with the second safety valve. We are close to the end of the heating phase. Let's take a look at the status to see how it is. The heating capacity is still 12 kilowatt. Everything is operating at maximum power. The mixing motor is running. The mash thermometer will alarm soon. The pressure of the jacket is low. Since we have vented it, everything is all right here. The cupola thermometer is currently showing approximately 70 degrees Celsius. We set the sound signal to 80 to 85 degrees Celsius. You can see its probe at the back. It measures the temperature of the steam in the pipe exiting the cupola. It will alarm us. You can already feel that the line arm is becoming hot, but the column elements are still cold. The start of the heads will be indicated when you can see through the sight glasses that reflux begins to form, and the column is warm to touch. Be careful to avoid scalding injuries. The entire column is still cold for now. The line arm is already heating up. We will see the reflux formation through the sight glasses soon. The boiling point was already determined during the previous distillation. We calculate it to be 95 degrees Celsius. Through the line arm, it will go down to the bottom of the rectifying column, and the concentration and operation of the rectifying column will begin. At the end of the heating phase, when the steam reaches the upper pipes, they are also hot. The cupola thermometer alarms us. At this point, we can already experience that the first part of the column is starting to heat up, and reflux begins to form. The cupola thermometer has already alarmed us. The temperature is going higher, and by this moment the steam has already come through. We can see it through the sight glasses. At this point, especially during the first attempts, turn down the heating power. A heating power of 4 kilowatt is more than enough in this case. This will give us time to observe the operation of the column and to start collecting the heads slowly, drop by drop, flowing like capillary. You can already experience that this column element is hot. The steam is here right now. You can feel it exactly as it moves upwards. At this point, the latest, we set the amount of water entering the deflegmator to above 160 liters per hour. This way we can ensure that all the steam that goes up in the column condenses in the deflegmator and then flows back down the column. You can see that the top plate is already full and bubbling evenly. During collecting the heads, all 3 level control levers are in the upwards position. As the top plate fills up, the reflux falls through the overflow to the middle plate, and then when the middle plate is full, it is transferred to the lower plate. When each column section is bubbling evenly, then we reduce the amount of water entering the deflegmator and release the heads. Now we can see that the entire system is starting to warm up, and the sensor in the swan neck coming out of the deflegmator also shows that the temperature is rising slightly. However, since there is quite a lot of water entering the deflegmator at this moment, the steam cannot break through the cooling resistance of the deflegmator at 4 kilowatt, so it all condenses and flows back down the column. We have to wait a little longer for each plate to bubble, and then we release the heads. We have replaced this sight glass. You can see that after a few distillations it is perfectly clean. The first few times you do a distillation, it's not always easy to see the process. After a short while, the plates will clear up and everything will be clearly visible from then. The operation of the top plate is perfectly visible now. Within a few minutes, each plate has filled up. They are bubbling evenly. You can see it most easily through the top plate, and they should all look like this. The material transfer is going perfectly. The upper part of the column is enriched with the heads and the more volatile components, which we will now release. So we let them go to the top, then through the line arm, go into the end cooler, and then flow out into the distilling parrot. The heads will flow through the parrot into the first collecting jar. We reduce the amount of water entering the deflegmator. 30-40 liters per hour will be enough for the heads to start at 4 kilowatt. After this, the temperature begins to rise within a short time. We can see on the deflegmator thermometer that it is increasing. Here you can see how well the column can be controlled, because if we increase the amount of water again at this point, and we look at the temperature, we will see that it drops almost immediately. So the manual control works perfectly. We can exactly see the volume flow through the rotometers. This was only for demonstration purposes. I set back the rotameter water flow to the lower value of 30-40 liters per hour, and let the temperature rise to 77-78 degrees Celsius, where the steam can pass through the deflegmator and will be transferred to the end cooler through the line arm. It only takes a few minutes for the heads to start. The sensor of the deflegmator thermometer already shows 77 degrees Celsius, which is the starting temperature of the heads. At this moment, the part of the line arm located above the end cooler is still cold, but the part located above the deflegmator is already hot. As the steam passes through the line arm and heats it up, the heads will start through the cooler. During collecting the heads, the level regulators, so the height of the overflow, is at maximum. It's at the highest level, in order for us to separate the heads in the smallest possible quantity and at the highest concentration. In case of good quality ingredient, we can expect a little amount of heads. We collect the heads in 50-100 milliliters fractions in the collection jars, which we previously numbered to see which was the first, most intensive heads-like fraction. And then we will subtract 4 to 5 pieces of 0.5 to 1 deciliters fractions, which we will later classify. We can take samples from the heads from time to time, and when we feel that the head's character has disappeared and the distillate flowing out has a pure heart's character, we can switch to collecting the hearts. The classification of the heads must be carried out exclusively by smelling. At the end of the heads collection, we close the tap on the distilling parrot, and we place the alcohol meter in the parrot. Let's take a look at the status at the end of the heads collection. We collected the heads at 4 kilowatt. The temperature during this time is 77-78 degrees Celsius. After collecting the heads, we can increase the power to 6 kilowatt. In case of good quality ingredients, we can set the level control levers of the upper 2 plates to middle position. This reduces the column's concentration ability and resistance, and allows the light, fragrant aroma characteristic of the first half of the hearts to easily pass through the column. We finished collecting the heads and moved on to collecting the hearts. The concentration at the start of the hearts is high. Approximately 94% alcohol is currently flowing out of the distilling parrot. During collecting the hearts, the temperature interval we would like to maintain is 79 to 80 to 81 degrees Celsius, and we need to control the amount of water entering the deflegmator with the rotameter accordingly. If we increase the amount of water entering the deflegmator, the temperature will decrease. If we reduce the amount of cooling water entering the deflegmator, the temperature will increase. At the moment, we need to set a water flow of 50 to 60 liters per hour in order to maintain the desired temperature interval with a heating capacity of 6 kilowatt. If the tenths on the deflegmator thermometer are going up, It means that we need to increase the volumetric flow of the rotameter. We can also do this by suddenly opening the rotameter. Then we will experience that the temperature reacts to it almost immediately and decreases. Then we will set back the rotameter to a higher value by a flow rate of 10 to 15 liters per hour, as where we started this so-called flooding. Our mash temperature is currently nearly 98 degrees Celsius. At this level, we can turn back the level regulators of the sieve plates to the upwards position, till they can concentrate as best as possible with maximum reflux, thus avoiding sour, heavy components entering the useful hearts during the second stage of the hearts. An interesting phenomenon is that the temperature of the line arm is 96.8 degrees Celsius, while the temperature of the mash is 97.8 degrees Celsius. It's due to the large copper surface why we can achieve a temperature drop of approximately 1 degree Celsius, even with air-cooled deflegmation. The air temperature is significantly cooler than this 96-97 degrees Celsius temperature, so the distillate vapors that are trying to rise are cooled by the large surface. It is due to the good thermal conductivity of copper. This helps us produce even purer, more fragrant distillates. Copper has a catalyzing role anyway. When the components entering the vapor space meet and collide, new aromas are formed, and the surface binding effect of copper helps us ensure that the sulfurous and other distillate components found in the mash attach when they get in contact with the red copper surface and do not enter the hearts. The third liter of this hearts is still flowing at above 86% of alcohol content. The water temperature leaving the end cooler is lower than what is optimal for us. It's not a problem, because only 50-60 liters of cooling water per hour flows through the end cooler, but we can reduce it a bit. As we discussed, the optimal temperature is between 50 to 60 degrees Celsius. At the moment, the thermometer is alarming us that the temperature is higher, so we change the amount of water flowing through the rotameter. As for the heating power, 6 kilowatt is considered optimal. At this stage, 6.57 kilowatt is still considered too much. Right now, the pot meter was at 40-50%. I just turned it off, so we can optimally collect the hearts around 6 kilowatt. Just for demonstration purposes, we increase the heating power to flood the column. This phenomenon occurs when, due to the heating power being too high, a large amount of steam is generated which would try to pass through the column. But we cannot let the temperature leave the interval of 81 degrees Celsius, so we are forced to continuously increase the amount of water entering the deflegmator. This will result in too much reflux forming, which will flood the column. This phenomenon is no longer good for us and is a clear sign of the heating power being too high. By reducing the heating power, the state will return to normal in a short time. We are at the end of the third liter and the alcohol content is still very high. This is a characteristic of this distillation method. While the flow rate slows down globally, the alcohol content will not decrease. This way we can ensure that we are able to collect the hearts free from tails contamination. It is important that this alcohol content will not decrease until the very end of the distillation. However, it will take more time for the given liter to flow out. We can achieve this by the previously discussed regulation, by letting enough water into the deflegmator through the rotameter so that the temperature does not leave the interval of 79 to 81 degrees Celsius. What temperature to be maintained depends on the style of the person doing the distillation. We have already collected 3.5 liters of concentrated hearts, with an average alcohol content of around 85%. Let's look at the status. We operated the machine with a heating capacity of 6 kilowatt, during almost the full collection of the hearts. The temperature is 80 degrees Celsius, and the mash temperature is already over 99 degrees Celsius. So at this point we can suspect that the distillation will soon be over, and the characteristic elements of the tails will appear. At this moment, the temperature of the steam leaving the cupola does not matter to us. The ratio also holds that the boiling mash cools by approximately 1 degree Celsius because of the copper surface. This will be more intense if we use the Pistorius plate during pot still distillation. The distillate flows with a high alcohol content, even at the end of the distillation, and at this time we must begin the continuous monitoring of the tails. There is an option to collect the distillate in half a liter, a few deciliters fractions. But typically after a little experience, it is no longer necessary. Plus the mash temperature helps us. We can see that the distillation will be over roughly between 99 and 100 degrees Celsius. Since the boiling point of water is 100 degrees Celsius, there will be no alcohol content at that point, or just a very minimal alcohol will remain, only as residual alcohol in the mash. We have several options for classifying the distillate to determine whether it contains any tails. One of the most common is to pour a little bit into a suitable tulip-shaped brandy glass and simply smell it. Once we have become familiar with the characteristics of the tails, it will be easy to notice if the distillate that is currently flowing has a sour so-called boiled pot tails character. When getting to know the tails, it is very useful to do a so-called skin test. This involves applying a little distillate to your hand, waiting until it evaporates and your skin is almost dry. And if now you feel a sour tails character, the other side effect of which is that the surface of your skin becomes sticky, then you know that you need to stop the distillation. That part of the distillate should be added to the hearts in only a small amount, if possible. Another option for classifying the tails is the so-called dry test. We pour a little distillate into our glass, then pour it out, and wait for most of the contents of the glass to evaporate. If we then smell it and experience sour smells typical of the tails, we can stop distilling. We have reached the end of collecting the hearts. Let's check the status and turn off the machine. 6 kilowatt heating power, 99.5 degrees Celsius mash temperature, deflegmator thermometer, 80 degrees Celsius, approximately 80 liters of cooling water per hour entering the deflegmator. We overcooled the end cooler, but it still only consumed 40 liters of water per hour. Our distillate, as discussed, still has a high alcohol content, 88 degrees. I emphasize that this is the very end of the distillation. We turn off the heating. The mixing motor can still operate at this point to prevent the mash from settling and possibly causing blockages, although this is not typical of a well-processed mash, which has a mushy consistency. The machine cools down a bit, then we start cleaning, backwashing, and rinsing the machine, and then emptying the waste material that remains in the kettle. Turn off the rotometers. The water supplies at the back of the machine can also be closed. There is also a tap on the other side. Put the alcohol meter in a safe place and drain the remaining contents of the distilling parrot. To rinse the end cooler, simply remove the parrot. Let's start rinsing the end cooler. You will need a bucket where the washing water can flow out. At the back, you have to open this water supply tap, and with this tap you can let water into the top of the cooler. This way, the entire cooler is rinsed with washing water. It is important that the water coming in is of drinking water quality. I turn on the tap and the washing water appears in a short time. After rinsing with a few liters, the tap can be closed. The first step is to loosen the door or even remove it, while being careful that hot steam may escape from the machine. To rinse the column, open the water supply tap of the column side, and by opening this tap, we can let the washing water into the top of the deflegmeter through this pipe. This way we can rinse the entire column. The washing can begin. The washing water enters the kettle at the bottom of the column and rinses the column's water seal as well. After a short wash, the tap can be closed. Before emptying the waste mash, we suggest cooling it down. In this case, the kettle can be filled up almost to the overflow level. We will see that the value on the mash thermometer continuously decreases. Emptying with a bucket is always an option, but there is a much more elegant and convenient solution as well. The machine spout can be connected directly to the sewer. You need to consider where the spout will fall in during installation. This is perhaps the most elegant solution of emptying the mash. The mash has cooled down to 70 degrees. We can begin emptying. It is important that the drain used for emptying is made of the appropriate heat-resistant pipe. Let's open the backwash. This also cools the mash and dilutes it. And open the drain tap. If the flow is too strong, we can close it a little. After emptying the waste mash, cool and rinse the kettle. After draining everything from the kettle, we can perform a final column rinse to make sure that the return pipe is clean. Turn off the mixer motor. The cupola of the Trias can be easily disassembled, allowing us to clean both the cupola and the kettle. Rinse the kettle again if necessary.